Hello. So I had a request to explain these complex number problems of TSEAMCET from Rahul from Telangana. So why don't we take a look at these problems? The first problem is if x plus iy is equal to 1 plus I raised to the power 6 minus 1 minus I raised to the power 6, then what is the value of x plus y? So with these competitive exams, you don't get more than a minute or maybe 2 minutes to solve these problems. So you have to be very quick, very fast. And then you get a problem like this, in which you have power 6 on an expression. So if I go on and do this, that this is equal to 1 plus I into 1 plus I raised to the power 5, then open the brackets by multiplying this with this first and then this with this first, then further open this bracket with 1 plus I into 1 plus I raised to the power 4. You will consume like at least 5 to 10 minutes, and by the time you're done the paper is over and you haven't done nothing. So you have to think critically, like, how do I get the expansion of this in less than a minute? So you have to utilize this very famous Euler's entity. So the problem now arises: how do I convert this into something like this? Okay, so we have to think is, let us write it like this: 1 plus I raised to the power 6 is equal to square root of 2. How did I get the square root of 2? I will explain a bit later. Plus I into 1 by square root of 2 raised to the power 6, and this will also get raised to the power 6. Yeah? So square root of 2 raised to the power 6 is 2 raised to the power 3 or 8. 1 by square root of 2 is what? Cos pi by 4. 1 by square root of 2 is also sin pi by 4. Raised to the power 6. Now this is a form which is looking like this, right? So my expression is reduced to my expression, which was 1 plus I raised to the power 6, get reduced to what? 8 into e to the power I pi by 4 and 6 here. So what we can do now is this: pi by 4 multiplied by 6 is 3 pi by 2. Okay, now I will use this again and write my e raised to the power I 3 pi by 2 as this: cos 3 pi by 2 plus iota sine 3 pi by 2. So this is 1 plus I raised to the power 6. Easy. Similarly, you can do this for 1 minus I raised to the power 6. This plus will become minus here, so essentially cos minus pi by 4 plus sine minus pi by 4. So it will be minus 3 pi by 2. When you take the minus out, it will get here. So, or you can just replace, so you can do all that, and just a sec, just a sec. Just a second. Um, so 1 plus I raised to the power, no. I was looking at, okay, so now we are looking at 1 minus I raised to the power 6. I have already done with 1 plus I raised to the power 6. So now 1 minus I raised to the power 6 is equal to what I have done above. It will be just the same, cos 3 pi by 2 minus I sine 3 pi by 2. So 1 plus I raised to the power 6 minus 1 minus I raised to the power 6 will be equal to 8 cosine 3 pi by 2 plus iota times 8 sine 3 pi by 2. Since there's a minus sign here, what we get is this 8 cos 3 pi by 2, and minus will become plus I times 8 sine 3 pi by 2. This will be cancelled. So 1 plus I raised to the power 6 minus 1 minus I raised to the power 6, which was given as x plus iy, is equal to I times 16 times sine 3 pi by 2. So x is 0 essentially. Now we need to know the value of this sine 3 pi by 2. So why don't we just draw the graph for sine, because I do not remember the value. So this is 0. This is a sine curve, right? So sine 0, pi, 2 pi. This is 1, which is at pi by 2. And this is 3 pi by 2. Correspondingly, you get minus 1. So x is 0 and y is minus 16. So x plus y is minus 16. So the answer is this. Now let us have a look at the second problem. It says I square plus I cube plus I4 plus I5 plus I6 plus I7 plus I8 plus dot 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 I raised to the power 4000. I square plus I cube plus I4 plus I5 plus I6 plus I7 plus I8 plus dot 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 I4000. So iota or I is a square root of minus 1. That is minus 1, square root of minus 1 is represented by iota. So iota square will be what? Minus 1. And iota cube will be what? This multiplied with iota, so minus iota. And iota raised to the power 4 will be plus 1. So your series is like this. iota square, iota 4, okay, iota 5. What will be iota 5? This will be just iota raised to the power 4 into iota. Iota raised to the power 4 is 1. 1 into iota is iota. So your series is this: minus 1 minus iota, plus 1 plus iota. Okay, consider 4 numbers at once. Then iota 6 will be again the same as iota square, which is minus 1. Iota 7 will be minus I. Iota 8 will be, iota raised to the power 8 will be 1. Iota raised to the power 9 will be iota. So if you go by pair of 4s, you will see that in this series the sum of 4 consecutive numbers is 0. But you have till iota raised to the power 4000, so you don't know whether this ends in 4 terms or not. So you have to find that out, which will be the last 4 terms. So if I have 3994 plus 3995 plus 3996 plus 3997 plus iota raised to the power 3998 3999 plus iota 4000. So these will be your last 7 terms. Of course, the 4th term is missing, which should have been iota raised to the power 4001. If 4001 was also here, then this would have also become 0. This is already 0. Your answer would have been 0. But since 4001 is not there, so what is this? This is minus 1, this is minus I, this is plus 1. So this and this will get cancelled. Your answer will be minus iota. Now the problem here is, how do I know that which power will be the series that will be here? Why shouldn't it be like 3996, 3997, 3998, 3999? Why isn't the series like this? Because this is an arithmetic progression, right? First term iota square of the 4 terms, then iota 6, then iota 10, iota 14. We will end up with this term. But how do I know it is this term? You have to subtract 2 from this number, 3994, and then you have to divide it by 4. If it's divisible, then this is your number. If it's not divisible, then you have to explore for other numbers. As far as we know, this will be 3992 by 4, which is 998. So it is divisible, right? So this is problem 2. Then we have to look at problem 3. If 1 omega and omega square are cube roots of unity, then a plus b plus c into a plus b omega plus c omega square into a plus b omega square plus c omega is equal to what? So this is a tricky problem. It's not too tough if you remember that 1 omega and omega square are cube roots of unity. Unity is what? 1. Then the sum of these 3 is equal to 0. We have to remember that. And you also have to remember this: product of the roots is equal to 1. 1 into omega cube, which is 1. Omega cube is 1. You have to remember that. So these two are important. This and omega cube equals 1. These two are important. So what do I have? I have a plus b plus c into a plus b omega plus c omega square. This is a lot of work. A plus b plus c into a plus omega plus c omega squared times a plus b omega squared plus c omega. You will have to open the brackets and see what is going on inside. So let us multiply these two first. Why do I want to multiply these two first? Because I know that omega times omega square will be omega cube, which is 1. So I have b omega and b omega square. If I multiply these two terms, I will get b square. If I multiply these two terms, I will get c square, because omega cube is 1. These two terms I will get a square. So it will be really easy for me. A times a square plus ab omega square, okay, plus ac omega. Alright, so now we multiply b omega. So a b omega, okay, ab omega plus b square omega cube. Omega cube is 1, so just b square. Then bc omega square. Okay, now we are left with this. We have multiply c omega square with this. So a c omega square plus bc omega raised to the power 4. Omega raised to the power 4 can be written as omega and omega cube. Omega cube is 1, so I can just write it as bc omega. C square omega cube is again c square, because omega cube is 1. So what do I have? I have a square, I have b square, I have c square. Okay. Now I have ab omega square and ab omega. Omega plus omega square. What is omega plus omega square? From here you can see omega plus omega square is -1. So you will get a plus b plus c into a square plus b square plus c square minus ab. Now we look at this bc omega square and bc omega. When you take bc common, you get omega square plus omega, which is again -1. So you get minus bc. Then you are left with only these two, ac omega and ac omega square. You take ac common, you get omega plus omega square, which is again -1. So you will be left with this. And we know that the expansion of this term is a cube plus b cube plus c cube minus 3abc. This is from class 11th. So this is the answer. This problem, if ak is cos xk plus iota sin xk for k is 1, 2 and 3, and a1, a2, a3 are roots of this equation, x cube plus bx plus c is equal to 0, then the real part of b is this. So I think this was the toughest problem for complex number in this paper. There were 4 problems. I think this one was the toughest. So the equation that we are given is x cube plus bx plus c is equal to 0. So I can write it like this. So from the properties of polynomials and their roots, which was in class 10th, we can say that sum of the roots is minus b by a. So b here is 0. So a1 plus a2 plus a3 is equal to 0, and a1 a2 plus a2 a3 plus a1 a3, which is equal to c by a. C here is b, a here is 1, so this will be b, and product of the roots a1 a2 a3 minus b by a plus c by a minus d by a. D is here is c, so minus c. So we will have these three, and this is 0, this is equal to b, this is minus c. He's asking what will be the real part of b. So ideally, I think this problem was not really clear. I think they should exclusively mention that b and c are real numbers, otherwise this will be really tough to solve. Okay, anyway, let us continue. What I want to say is that c should be a real number, otherwise we will not be able to solve this problem. A1 plus A2 plus A3 is equal to 0. That means cos alpha 1 plus iota sine alpha 1. So A is defined as, AK is defined as cos alpha k plus iota sine alpha k. I've written x over here, sorry. So A1 is equal to cos alpha 1 plus iota sine alpha 1. A2 is equal to cos alpha 2 plus iota sine alpha 2. And A3 is equal to cos alpha 3 plus iota sine alpha 3. Okay, so we will have to write A1 plus A2 plus A3 is equal to 0. This will be written in this form. And this is given to us as 0. So we know that the real part, this one, is equal to 0, and the imaginary part, which is this one, is equal to 0. So we know that cos alpha 1 plus cos alpha 2 plus cos alpha 3 is equal to 0, and sin alpha 1 plus sin alpha 2 plus sin alpha 3 is equal to 0. And A1, A2, A3 is equal to minus C. So A1 is this, it will be multiplied with this, it will be multiplied with this. It will be a nightmare if we try to solve it. So how do we go about it? How do I solve it? I will use this. Right? So when I multiply these three, I will just get some of these thetas over here. So cos theta 1 plus iota sine theta 1, or we have alpha over here, sorry, sine alpha 1 into cosine of alpha 2 plus iota sine alpha 2 into cosine alpha 3 plus iota sine alpha 3. This will be the product of the roots. So this is what this will be: e to the power iota alpha 1 into e to the power iota alpha 2 into e to the power iota alpha 3, which will be equal to e to the power iota alpha 1 plus alpha 2 plus alpha 3. Now I can write it as cos alpha 1 plus alpha 2 plus alpha 3 plus iota sine alpha 1 plus alpha 2 plus alpha 3. Now this was given equal to minus c. What I wanted to say that c was a real number, otherwise this would be really difficult to solve, right? We will not be able to solve this problem if c was not real, or it would be much more effort which couldn't be done in like 1 or 2 minutes. So if this is a real number, then this has to be 0. So when is the sign 0? At 0 or at pi or at 2 pi? just for the sake of simplicity, we will stick with 0. So alpha 1 plus alpha 2 plus alpha 3 should be 0. Now we look at b. The real part of b is cos alpha 1 plus, sorry, where is b? Yeah, b is here. a1 a2 plus a2 a3 plus a1 a3. Let us write the real part of b first. Real part of b, which is real part of a1 a2 plus a2 a3 plus a3 a1. Okay, so we will have to solve this just like what we did over here. Change this to e to the power iota alpha 1, then multiply. So you will get real part will be cos alpha 1 plus alpha 2. What will be the real part of this? Cos alpha 2 plus alpha 3 plus cos alpha 3 plus alpha 1. Now we know that alpha 1 plus alpha 2 plus alpha 3 is 0. So I will write alpha 1 plus alpha 2 as minus alpha 3. I will write alpha 2 plus alpha 3 as minus alpha 1. And I will write alpha 3 plus alpha 1 as minus alpha 2. Now we know that cosine of negative of an angle is just that angle itself. So cos alpha 3 plus cos alpha 1 plus cos alpha 2. So it is cos alpha 1 plus cos alpha 2 plus cos alpha 3. Now we also know that the sum of the roots is 0 because this is the equation that is given to us. So sum of the roots is already given to us as 0. So from there we derive that cos alpha 1 plus cos alpha 2 plus cos alpha 3 is 0. So this number is 0. So real part of b is equal to 0 here. So if you encounter a problem like this which is really tough and you're not able to go ahead, better skip that problem rather than wasting 10-15 minutes on a single problem. Oh, okay, bye.